Double the guard, zero the downtime. Ruijie RGWALL 1600Z S-Series cloud-managed firewalls enable HA functionality.
Firewalls are designed to offer robust security features for defending against a wide range of cyber threats. If the firewall fails, the protective shield is compromised. This exposes an enterprise to risks such as unauthorized access, malicious traffic intrusion, and data leakage, and can also disrupt normal service traffic, leading to network breakdown. Therefore, it is very important to ensure seamless network security defense with minimal downtime, in order to support continuous and reliable services. When a single failure occurs on a traditional firewall, network traffic needs to be switched to the passive firewall.
However, existing TCP sessions are interrupted during the active-passive failover,
and user information cannot be synchronized after the failover. Emergency rescue for network breakdown. How can active-passive firewall failover achieve uninterrupted services for video conferences? The high availability function of Ruijie's firewalls is a critical feature designed to ensure continuous network security and uptime. Combining HA, advanced threat protection, and ease of management, ZS series firewalls apply to various business scenarios, from small and medium enterprises to large corporations. The firewalls can be deployed in active-active or active-passive mode. This video demonstrates only the active-active mode. In active-active mode, two firewalls process services simultaneously, improving the system load balancing capability. If one firewall fails, the other firewall takes over its services immediately, ensuring service continuity.
Suppose you have already deployed a Ruijie RGWALL 1600Z 5100S firewall.
Then how can you activate the HA function? First, you need to order another firewall of the same model to serve as the passive firewall. On device A,
connect GE01 and GE03 to the downstream switch and connect GE02 and GE04 to the upstream switch. Connect GE06 on device A to GE06 on device B to function as the heartbeat interface.
On device B,
and connect GE07 on device A to GE07 on device B to function as the data synchronization interface. Connect GE01 and GE03 to the downstream switch and connect GE02 and GE04 to the upstream switch. Connect GE06 on device B to GE06 on device A to function as the heartbeat interface. And connect GE07 on device B to GE07 on device A to function as the data synchronization interface.
After completing connections according to topology, power on all devices. Assume that the routing mode is used.
IP addresses used for HA networking are as shown in this figure.
Log in to eWeb of the firewall to configure HA. First, configure HA on device A. Choose System, High Availability, HA Settings. Toggle on HA to enable HA. Set HA mode to active-active. Enable security authentication.
Select GE06 as the heartbeat interface and set the remote IP address to 172.16.1.2,
which is the IP address of the heartbeat interface on device B.
Select GE07 as the data synchronization interface.
And set the remote IP address to 172.16.2.2, which is the IP address of the data synchronization interface on device B. Configure Group 0. Set the priority value to 200.
Select GE01 and GE02 for interface monitoring.
Configure Group 1. Set the priority value to 100.
Select GE03 and GE04 for interface monitoring.
Enable the preemption mode and set the preemption delay to 60 seconds.
Select GE00 as the management interface.
Click Save to deliver the HA configuration. Then configure HA on device B. Choose System, High Availability HA Settings. Toggle on HA to enable HA. Set HA mode to active. Enable security authentication.
Select GE06 as the heartbeat interface and set the remote IP address to 172.16.1.1,
which is the IP address of the heartbeat interface on device A.
Select GE07 as the data synchronization interface,
and set the remote IP address to 172.16.2.1, which is the IP address of the data synchronization interface on device A. Configure Group 0. Set the priority value to 100.
Select GE01 and GE02 for interface monitoring.
Configure Group 1. Set the priority value to 200.
Select GE03 and GE04 for interface monitoring.
I'll enable the preemption mode and set the preemption delay to 60 seconds.
Select GE00 as the management interface.
Click Save to deliver the HA configuration. After HA is configured, in Group 0, Device A is the active firewall, and Device B is the passive firewall. In Group 1, Device B is the active firewall, and Device A is the passive firewall. In this way, service traffic can be load balanced between the two firewalls. Choose System, High Availability, HA status to view the device status. After the network is successfully set up, the current running mode is active, and the device running status is normal. Click Synchronize now and check whether the synchronization status is success. The active and passive firewalls establish an HA connection through heartbeat interfaces and data synchronization interfaces. The two firewalls in each HA group periodically send heartbeat packets to each other to notify their local status, priority, and other information. Reliability of heartbeat detection is related to the interval for sending heartbeat packets. A smaller interval indicates higher reliability. On the firewall, the default heartbeat interval is 1 second. On eWeb of device A, choose ONM, Fault Diagnosis Packet Obtaining Tool. Click Start. In the dialog box that is displayed,
select the heartbeat interface GE06.
Set Layer 2 protocol to IP and Layer 3 protocol to UDP, and click Start. Click View in the operation column. Enter IP src 172.16.1.1 in the input box. Check whether the interval for sending heartbeat packets is 1 second. Visit the Ruijie official website and play a video. Check whether the video can be played properly. On the client, check whether files can be downloaded from the FTP server. Choose O&M Network, Traffic Real-Time Traffic.
Check whether GE02 on device A in Group 0 has real-time traffic, and whether GE02 on device B in Group 0 has no real-time traffic. Check whether GE04 on device B in Group 1 has real-time traffic, and whether GE04 on device A in Group 1 has no real-time traffic. Check whether device running status of both firewalls is normal, and whether load balancing of service traffic is implemented between them. Common network faults include the following. A software or hardware failure occurs on the active firewall, resulting in system suspension or reset of the active firewall. The active firewall is powered off or restarted. For example, a module on the firewall is removed. A failover is performed manually. Now, let's simulate the most severe hardware failure to see what the outcome will be. The HA function of Ruijie firewalls enables rapid traffic switching. In this way, user applications are not disconnected due to packet loss, and video playback and file download are not interrupted.
The seamless active-passive failover process guarantees a continuous end-user experience. Double the guard, zero the downtime, secure your network.